Hello, we're going to work through the problems assigned out of section 3.3. First up, we're given g of x is negative, the quantity x minus 2 squared plus 1. We're asked find the vertex and axis of symmetry of the quadratic function. So quadratic functions can come to us in two different forms typically. First, we may have something like f of x is ax squared plus bx plus c. And if you're used to working with the quadratic formula, this is how you are used to working with quadratic functions. However, we may also have it in what's called, this is standard form, by the way. We may also, however, have it given to us in what's called vertex form, which is ax minus h squared plus k. If it's already in this form, the vertex is going to be at the point h, k. Okay. It is concave up if a is positive. It's concave down if a is negative. Now, I would like to point out the a in vertex form and the a in standard form are actually the same a. This b and this c are related to this h and k, but they are not equal to it. The a, however, will be the same between the two forms. Okay, so even if it's given in standard form, if a is positive, it opens up, it is concave up. If a is negative, it opens down or is concave down. Also, the axis of symmetry is the vertical line that goes right through the vertex. So in this particular case, it's given to us in vertex form. So the vertex is at exactly positive 2, 1. Now, why positive 2? Observe that in the formula for vertex form, there should be a negative sign here. Okay, so positive 2 corresponds to x minus 2. So the vertex is at 2, 1. This means that the axis of symmetry will be at exactly x equals 2. Okay. It is concave down because the number out in front, our a, is negative 1. And then we can pretty quickly graph this. Okay, so I'm going to draw a generic concave down parabola. Then I can label the vertex at 2, 1. We could also draw the axis of symmetry, x equals 2. And that's a pretty serviceable graph. If we didn't have to plot any more points, then we're fine. All right, here we have a quadratic function at negative x squared plus 4x, and we are given three things to say about it. So graph the quadratic function by determining whether it opens up or down, finding its vertex, axis of symmetry, y-intercept, x-intercept, if any. Okay, so this is not in vertex form. This is in standard form. However, we do have a equals negative 1. Okay, the number multiplying x squared is negative. This tells me the parabola will be opening down. Okay. Now, if we have a function, which is a parabola in standard form, so the vertex, or more to the point, sorry, the axis of symmetry will be x equals negative b over 2 times a, and the vertex has to go through that for its x-coordinate, and the y-coordinate of the vertex is simply whatever you get out when you plug that into the function f. Okay, so here, well, we quickly determined this was opening down just by looking at the coefficient of the x squared term, the number multiplying the x squared term, and seeing it's negative, so this is a downward opening parabola. To find its vertex, we're going to rely on this formula right here. So b is equal to 4 and c is equal to 0. So in this particular problem, my axis of symmetry is x equals negative b over 2a, or 4 over 2 times negative 1, with a negative on top, I apologize, negative 4 over negative 2, or just 2. So x equals 2 is the axis of symmetry. So what's the vertex? 2, f of 2. So let's go ahead and compute f of 2. It's negative 2 squared plus 4 times 2. Negative 4 plus 8, or 4. So the vertex is at the point 2, 4. Okay. As long as we're at it, we are also asked to compute various intercepts. Okay. So the y-intercept is what happens when you plug in 0. So this is going to be negative 0 squared plus 4 times 0. Everything works out to just be 0. So the y-intercept is just 0. The x-intercept, or possibly intercepts, is what happens when you solve f of x equals 0. So I end up with 0 equals negative x squared plus 4x. Observe I can factor an x out of this, okay? Leaving behind negative x plus 4. So now what we have is I have 0 is equal to one number, x, times another number, negative x plus 4. What values of two different numbers could I have that multiply together to 0? Well, the only way two numbers can multiply together to be 0 is if one of them is 0. So either the first number is 0 or the second number is 0, and that second number is negative x plus 4. But how can negative x plus 4 equal 0? Just simply by adding x to both sides, we see that x equals 4. So there are in fact two x-intercepts. X equals 0 or x equals 4. Okay, so finally, we can plot all of this information and draw a graph, which I will do in this upper right corner by erasing some of this generic information about how to find the vertex of any old parabola in standard form. Negative b over 2a is the x-coordinate, and then you simply plug that into the function to determine the relevant y-coordinate. So in this particular problem, we have a vertex of 2, 4, so that will be about here. Okay, if I was to start putting tick marks down on these axes, something like that. This is about at 2, 4. It's also opening down. So I know as I leave this, I want my parabola to start opening down. Okay. It has a y-intercept of 0. So if x equals 0, I also have y equals 0. Notice that this also tells me if I want y to equal 0, I can have x equals 0. That's this x-intercept, the first one. But 1, 2, 3, 4, x equals 4 is also a y-intercept. So my downward opening parabola will go through these 2 points. And I'm not terribly good at drawing, but something like this. And observe that x equals 2 is our axis of symmetry. And that closes out part A, which is the longest part of this problem. Part B says determine the domain and range. Now, domain for a function simply asks what values of x, of the independent variable, can you plug in? What are allowable things to compute here? Now, our function is negative x squared plus 4x. Every number can be squared, and every number can be multiplied by 4, and any two numbers can be added together. So there is no value for x for which I can't possibly compute negative x squared plus 4x. They might be difficult, but I'm talking, is it possible at all? The types of functions that have restrictions on their domain are things like square roots, because we don't want to take a square root of a negative value in this course. Also, anything that has a quotient in it, I don't want to ever divide by 0. Those will be the two principal ways that certain values of x might be excluded from a domain in this course. But in this case, we have no quotients and we have no square roots. Every value of x is legitimate, so for part B, the domain is all numbers. Sometimes written as all real numbers, but in this course, real numbers are all that we work with. The range, on the other hand, is what y values can I get out? Now for this, let's refer to the graph. Okay? Any x value can be plugged in, but I don't get out any possible y value. Notice that a downward opening parabola has a highest point on it. I will never get a y value above this one, and this has a y value of 4. But I do get out everything below this y value. So overall, my range are all y's less than, but also equal to 4. A downward opening parabola will always have a range of y less than or equal to the y-coordinate of the vertex. An upward opening parabola, in contrast, would be y's bigger than or equal to the y value of its vertex, because if the parabola opens up, you're going to get out all y values above that vertex value. Part C. Where is this function increasing? Where is it decreasing? In contrast to lines back in section 3.1, parabolas are going up, then they hit the vertex and they change, and now they are coming down. If it's an if it is a concave up parabola, it is decreasing until its vertex and then increasing away from it. So looking at this particular picture, we are increasing when x is anything from minus infinity up to 2. Once I reach that x value of 2, I have reached the vertex and I'm no longer increasing. And then once I pass that point, now the function is decreasing. Okay, moving on. So now we have a very similar problem. Okay, we just have another quadratic polynomial. X squared plus 6x plus 9 is f of x, and we're supposed to answer a bunch of similar information to the previous problem with some more steps thrown in there. So we find our vertex. This is going to be x is given by negative b over 2a. B is the number multiplying x, which in this case is 6. And a is the number multiplying x squared, which in this case is 1. And this works out to be exactly minus 3. Then I need to plug minus 3 into the function f of x to find the relevant y-coordinate of the vertex, and we get negative 3 squared plus 6 times negative 3 plus 9, or 9 plus negative 18 plus 9. Everything cancels, and I just have 0. So my vertex is at x equals negative 3 and y equals 0, and my axis of symmetry is exactly x equals negative 3. The number multiplying x squared was 1, so this is a concave up quadratic. Okay. To find y-intercept, we let x equal 0, and I simply compute what is f of 0. 0 squared plus 6 times 0 plus 9, which is just 9. Observe that if you ever had ax squared plus bx plus c, a standard form parabola, and you plug in 0, you end up with a times 0 plus b times 0 plus c, or c. This constant at the end, c, always represents your y-intercept, when the parabola is written in standard form, that is. Okay, so we found our intercept was y equals 9. To find our x-intercept, we let y equal 0, and I have 0 should equal x squared plus 6x plus 9. This happens to factor pretty nicely as x plus 3 times x plus 3. How can the product of two numbers be 0? Well, either the first number is 0 or the second number is 0. Well, these two factors are identical, so I don't really need to worry about that second one. It's the same as the first. And I get x equals minus 3. So there is our only x-intercept. Okay. Use parts a and b to graph the function. So here we'll put our coordinate axes. The vertex is at negative 3, 0. Okay, the parabola opens up away from here. It is symmetric around the line x equals negative 3. The y-intercept is 9, so pretty far up here we're going to have the point 0, 9. And x equals negative 3 is the only x-intercept, so there is nowhere else that it's going to touch this axis. Okay. Find the domain and the range. So the domain for any quadratic is all real numbers. The range, however, is not. Okay, never. We have an upward opening parabola, which means the range is everything bigger than or equal to the y-coordinate of the vertex. So domain is all reals because every polynomial has domain of all reals, and quadratics are a type of polynomial. So every quadratic function, the domain is all real numbers. The range, on the other hand, since we are opening up, it is all y's bigger than or equal to. Bigger than or equal to what? The y-coordinate of the vertex, which in this case was 0. So because it is opening up, the range is y's bigger than or equal to something, bigger than or equal to the y-coordinate of the vertex, and in this example, the y-coordinate of the vertex is 0. Okay, part E. Determine where the function is increasing and where the function is decreasing. So the change between increasing and decreasing always happens at the vertex. An upward opening parabola, as we have here, is decreasing until it gets to its vertex, and then it is increasing. It's the reverse for a downward opening parabola, but here we are increasing for everything up to decreasing for everything up to the vertex, and then we are increasing for everything after the vertex. Where is f of x bigger than 0 and where is f of x less than 0? So this is an interesting possible typo in the problem, but I will do it as written. Okay, so look at the graph of this function, and the question to ask is, where is the height larger than 0? Now, your first impulse, based on the picture on the left of the screen, might be to say the height is always bigger than 0, but that's not quite true. Okay. Where is y bigger than 0? All x except x equals -3. At x equals -3, the height equals 0, which means it's not bigger than 0. So we can write this as everything up to -3 union everything after -3, but specifically excluding the value -3. Where is y less than 0? Nowhere. There are no x values where f of x is less than 0. There is exactly one value where f of x equals 0, but if you refer to the wording of part f, we are never asked where is f of x equal to 0. Just where is it bigger than 0 and where is it less than 0. Okay, so moving on. So in this problem, it looks very different from what we've done before. Rather than being given a function and asked to graph it, we're actually given a graph, and we are asked to figure out what the function is that produces this graph. Something to note, however, is down here, we are given the vertex of this parabola. So if I rely on vertex form of a parabola, which remember was a times x minus h squared plus k, where the vertex is at h comma k, we immediately see that f of x needs to be a, which I still don't know, but here I get x minus 3 squared plus -11, or x minus 3 squared minus 11. Now the only thing we don't know is a. Everything else is totally known to us at this point, but a is not known. Okay, we do know that since this parabola opens up, a must be positive, but just knowing a number is positive is, alas, not very specific. But we do have more information. We have this point right here, this intercept of 0, -2, which means f of 0 must equal -2. But f of 0 is also equal to a times 0 minus 3 squared minus 11, because that's what I would get when I plugged x equals 0 into the vertex form that we already found up here. 0 minus 3 is -3. -3 squared is 9. So -2 is equal to 9a minus 11. We're going to go ahead and add 11 to both sides. 9 is equal to 9a. Divide by 9. And a is equal to 1, which is positive as we knew. So observing earlier that a needed to be positive didn't tell us the answer. But if we had made a mistake and found a negative value here, we would have immediately known, wait a minute, something went wrong. We needed a positive value of a. But we found a positive value of a, so that's all quite consistent. So down here on the left, we have vertex form of 1 x minus 3 squared minus 11, or just x minus 3 squared minus 11. Now, parabolas might be required to be given in standard form rather than vertex form. This problem didn't specify that, but sometimes MyLab can be a little particular about how you enter in your answers. So if you entered it in this form and MyLab told you, oh, wrong, perhaps it was expecting not vertex form, but standard form. And the only thing you have to do then is expand everything out from vertex form. Okay. So we're going to take our vertex form, x minus 3 squared minus 11, and we're simply going to expand everything out and simplify. So if we were required to give this in standard form, we'd say, okay, fine. If I expand out x minus 3 squared, that's going to be x minus 3 times x minus 3. I FOIL this, we get x squared minus 3x plus 9, and I still have the minus 11 hanging off at the end. Or x squared, I have minus 6x, and then I have a 9 minus 11 for minus 2. So if we needed the parabola in standard form, we have now done that. However, vertex form is a perfectly legitimate way to write parabolas. Okay. This problem didn't actually specify it has to be in standard form, so any reasonable person would accept vertex form. Of course, MyLab sometimes is not too reasonable. But moving on. Here we have the graph of a function, and we are told what its vertex is and another point that it goes through, and asked find ABC, which note is exactly standard form. So this is very much like the last problem, It's just we don't have a graph in front of us, but we are told the vertex and another point. So we're going to do this the same way. F of x is a times x minus h squared plus k, where the vertex is h comma k. So using the first coordinate of the vertex is 0 and the second is 3, we get a times x minus 0 squared plus 3, ax squared plus 3. We don't know the value of a, but we're going to use the other point to now figure this out, okay? 9 must equal f of 1, but f of 1 is a times 1 squared plus 3. So 9 must equal a plus 3. Subtracting 3 from both sides gives me a equals 6. Then I go back to the form I already have, and we have f of x equals ax squared plus 3, aka 6x squared plus 3. Find a, b, and c. A equals 6. C is the number being added on here, that's 3. But what does b represent? Referring to standard form of a parabola, b is the number multiplying x. A is the number multiplying x squared, b is the number multiplying x, and c is the constant hanging off. In our expression, the number multiplying x squared is 6, 3 is hanging around not multiplying any x's, but what number is multiplying x? It's not there, meaning it's there multiplied by 0, so b is 0. Okay, now we've got a parabola and we are asked to find its vertex. So it's in standard form, which means the x-coordinate of the vertex is given by negative b over 2a, which is negative 4 over 2 times 1, which simplifies down to negative 2. The y-coordinate of the vertex is found by plugging that value of x into the function. So we have negative 2 squared plus 4 times negative 2 minus 12, or 4 minus 8 minus 12, which works out to be negative 16. So the vertex is at the point negative 2, negative 16. What are the x-intercepts of the graph f? There we say, let's let y equal 0. So 0 equals x squared plus 4x minus 12. Now this quadratic factors fairly nicely as x plus 6, x minus 2. Okay, how do I now know this product of two numbers is 0? One of the two numbers must be 0. Either x plus 6 equals 0 or x minus 2 equals 0. In other words, x is minus 6 or x is equal to 2. So I have two distinct x-intercepts. And finally in part C, which I'm going to start back up at the top here, solve f of x equals negative 12. So I set negative 12 is equal to f of x, but f of x is also equal to x squared plus 4x minus 12. So negative 12 is equal to x squared plus 4x minus 12. I can add 12 to both sides and just get 0 is equal to x squared plus 4x, which factors as x times x plus 4. Now how can a product of two numbers equal 0? Either the first is 0 or the second is 0, and this second term tells me x is minus 4. So if I want to solve f of x equals negative 12 for x, there are two solutions. Either x is 0 or x is negative 4, giving me two different points on the graph. If x is 0, y is negative 12, but if x is negative 4, y is also negative 12. So these are 2 points on the graph of the function. Finishing part C. All right, and we close out with another revenue function. Okay, here our revenue function is given as a quadratic, 75x minus 0.2 times x squared. The monthly cost function is a linear function, 30x plus 1750. How many wristwatches must the firm sell to maximize revenue? So observe that revenue is a parabola, it's a quadratic function. The number multiplying x squared is negative, it is negative 0.2, which means it is a concave down parabola and therefore has a maximum. The maximum is at the vertex. So the coordinates of the vertex, x is given by negative b over 2a. Now look up here at the revenue function. What is b and what is a? A lot of people would look at this and immediately say b is negative 0.2 and a is 75, but they're not in the standard order. Okay, b doesn't just mean the second number and a doesn't mean the first number. b is the number multiplying the x term, and a is the number multiplying the x squared term. So b is actually 75, and a is actually negative 0.2. Okay, the negatives cancel out, that's great, but I'm going to go ahead and use a calculator to quickly tell me that negative 75 over 2 times negative 0.2 is 187.5. Okay. However, I can't sell half of a wristwatch. Okay. So our axis of symmetry is right here at x equals 187.5. I can't sell half of a wristwatch, so I can never actually achieve this vertex as my revenue. But due to symmetry, if I move 1/2 unit to the left or 1/2 unit to the right, I'll be at the same height. So either 187 or 188 watches will produce the same revenue. Okay, so what is that? I'm going to go ahead and plug in f of 188. Okay, so what I compute is, excuse me, 75 times 188 minus 0.2 times 188 squared. Okay, the only reason we're doing 188 instead of 187.5 is because you can't sell half of a watch. You know, not legitimately. Minus 0.2 times 188 squared for 7,031.2. In other words, $7,031.20. Now in this case, the decimal part is fine. 20 cents is still doable. So there's our maximum revenue, $7,031.20. Part B, profit is just given by R of x minus C of x. R of x was explicitly 75x minus 0.2x squared. Subtract C of x is 30x plus 1750, and observe I'm being very liberal with my use of parentheses so that I don't make any distribution errors. So I have 75x minus 0.2x squared minus 30x minus 1750. Putting this into the standard order would give me negative 0.2x squared. Then I have 75x minus 30x for a net result of positive 45x. And I wrote 44. Let me fix that. 45x. And then I have minus 1750. So here is our profit function. Part C, we're asked, go ahead and maximize profit. Generally, in a business, you are interested in maximizing profit, not just revenue. Okay, revenue is how much you're taking in, but profit is how much you actually get to keep. Okay, it doesn't really do you much good to take in a whole bunch more money if you're spending a bunch more money to do it. But this revenue function, this profit function, negative 0.2x squared plus 45x minus 1750, is still a downward opening parabola. It has a maximum. It occurs at the vertex. So we do the same work. I want x to be negative b over 2a. The number multiplying x is now 45, and the number multiplying multiplying x squared is still negative 0.2. And quickly computing, negative 45 divided by 2 times negative 0.2, 102.5. Sorry, I said 102 and I wrote 112. It's 112.5. Okay, I still can't sell half of a wristwatch, but this still has symmetry, so either 112 or 113 will give me the same maximum profit. So we may as well round that up to 113. So the profit function for 113 will be our maximum. That's going to be negative 0.2 times 113 squared plus 45 times 113 minus 1,750, which if I quickly go ahead and compute, negative 0.2 times 113 squared plus 45 times 113 minus 1,750, $781.20. $781.20. So there is our maximum profit. Observe that this maximum profit is smaller than the maximum revenue, which we found earlier, because that makes sense. Revenue, you'd have to then pay out costs, leaving behind less profit. The important thing to note, by the way, is that the maximum profit was for a different number of watches as the maximum revenue.